Welcome to a presentation on how to conduct chi-square test of independence using SPSS. In this presentation, we'll briefly cover the terms and considerations for conducting a chi-square test of independence, how to enter your data. We're going to actually use a shortcut method different from what is shown in your textbook, how to conduct the test, interpret and present it, and how to graph it. The chi-square test of independence is only for nominal data. It can be akin to ANOVAs to ask about differences or correlation to ask about a relationship. However, both of those tests require scale data, whereas for a chi-square test of independence, you can have multiple nominal variables. The scenario we are going to use in this example is listed on the screen. Please pause the presentation to read it quietly to yourself and also look at the data presented. We will start data entry in variable view. We had two variables, whether they were willing to hand out their phone number and what type of music was being played. But in variable view, we'll be first entering a variable we will name as weight. This is going to be the scale or numerical values we saw in that contingency table. So go ahead and name your first variable weight, and it won't have any value labels, and the measurement will be scale. After that, you will enter however many nominal variables you will be examining for your chi-square test of independence. In our particular scenario, we have two. We have whether they are willing to give their phone number and what type of music being played. So for the phone number, I named the variable phone, and as shown here, we would need to enter the value labels as being yes or no. Then we would need to go ahead and make sure that that scale of measurement is set as nominal. For the next variable, it was music type, and we would enter our value labels also as shown here. We have three: romantic, rock, and classical, and that is also nominal variable. Once you have all of the data set up so that it looks like this, then we will go to data view and enter the numerical values. In data view, we first will enter our weight column. We will have all the values shown in the 2x3 contingency table. I always start off from left to right. So I enter them as shown here. Then in the column phone, that corresponds to the columns in the contingency table. So yes was 1 and no was 2. So we would first enter 3 1s and then 3 2s. And that's because we had 3 rows of yeses and 3 rows of no's. Check to make sure the data matches the weight column. So as shown here, the yes green for romantic equals a 13, with yes for the phone, yes to the phone should be a 3, and yes to the phone should be an 8, and then also the no's should be 11, 20, and 14. Our second nominal variable was music type. We had 3 different types, and they should align to what is shown in this way. The column music should correspond to the rows in the contingency table as shown here. Now, we need to weight our data to prepare for the analysis. To do so, click on the tab that says Data and go to Weight Cases. Move Weight into the box and click OK. Now we can run our analysis. To run the test, you click on the tab Analyze, go to Descriptive Statistics, and select Crosstabs. You will move your variables as shown here, and make sure you click the Display Clustered Bar Chart as shown here in the hot pink area. Then you want to click on the box that said Statistics to open up a new dialog box where you want to make sure that chi-square and then our 2 types of effect sizes are shown. We're going to go ahead and have the contingency coefficient, pi, and Kramer's V all shown, even though we should know which one that we need to report. In this particular example, it will just be Kramer's V, but I'll cover that on the next slide. Once you select all of those, click Continue to close that dialog box, and then you'll select the tab right underneath it that says Cells. In that dialog box, you want to make sure you have selected the Observed and Expected. Then you click Continue and OK, and it will conduct your analysis for you. Now, just as a recap, I know this is in your textbook, but sometimes it's good to just have it out here. The effect size for chi-square depends on the type of contingency table you have. So we will run a pi squared if we have a 2 by 2 contingency table. So if you have two nominal variables and each nominal variable has two levels. The Kramer's V will if you have unequal numbers of rows and columns, so like a 2 by 3 or a 3 by 4 or a 2 by 5. Then we would use the V squared. And then the contingency coefficient would be if we have even numbers of rows and columns, but it's bigger than 2. But regardless of the effect size we report, all of them can be interpreted the same way. It's the percent variability accounted for in the frequency of one variable by knowing its relationship with the second variable. Now, SPSS will give us the effect size, but it doesn't give us the squared value, so we do have to square them before reporting them. And in our particular example, we will be using the Kramer's V because we have a 2 by 3. Right, here's our SPSS output. In the top, we see the music by phone crosstabs. It lets us check our entries to make sure that we have correctly set up our data. So you can check your counts. They should match up with what was shown in the original data. And then the expected counts is what SPSS calculated for you. What we want to look at though is the white box below that says the chi-square test, and you want to read the Pearson chi-square line. We see our chi-square value is an 8.791, 2 degrees of freedom, and our p-value or significance value is 0.012. That is below our alpha value, so it's significant. Yay! And then we also need to know our number of valid cases, 69, to be able to write up our full statistical notation. The only other thing we are missing from this would be our effect size, and as we just covered, we would be reporting the Kramer's V. Our value is 0.357, but we do have to square it, so our Kramer's V squared would be a 0.127. Taking all of that together, we can now write our statistical notation, which I have highlighted in the yellow box here. I would go ahead and pause this slide and just make sure you can see where all these numbers come from. Okay. We selected features so that SPSS would produce the appropriate graph for the chi-square test of independence. This is a clustered bar graph. From it, you can interpret the significance by talking about the trends you see. However, first, you do want to make sure that you format it so that it's in APA conventions. So you do have to remove the grid lines and make them solid covered boxes before you copy and paste it into a Word document. But this is an example of what a properly formatted APA clustered bar graph should look like for a chi-square test. Now that we have all of that put together, pause your slide and try to come up with a APA style result section for an independent, a chi-square test of independence, and then you can check your write-up with mine on the next slide and see if they are similar. Here's a sample of how you would write up the results. You first clarify the type of test being conducted, then you report the statistical findings and whether they were significant. You will always include and interpret the effect size and interpret what it means, and since we have a figure, we need to include a call out. Yours doesn't have to look identical to this, but it should be pretty similar, and the statistical notation should be identical. However, if you have any questions about this at all, definitely feel free to ask your instructor. And that is it for this brief presentation. Hope you enjoyed it.